Okay, very good morning to all of you. We are going to now continue with the topic of how to apply electric flux. That was the thing we did last. So in today's class, actually, we'll begin with the concept of solid angle. So suppose there is a area, plane area. Suppose the area is equal to A, and the corners of this area are subtending some angle at a distance r, like each vertex is at a distance r from this corner. So the angle that is subtended over here, this is a three-dimensional angle, so we call it a solid angle. So according to definition of solid angle, it is equal to this plane area divided by r square. And solid angle is measured in steradians. Okay, solid angle is measured in steradians. So the angle that you are obtaining over here, that is given by this area divided by r square, and it is measured in steradian, that is the unit. Now basically what happens, that suppose if this plane area it is a part of a very large object like a sphere. Okay, so this plane area, let us say it is on the surface of a sphere. So in that case, you can take patches of area like this on the surface of the sphere, and for every patch you can get the solid angle. So the question is, what will be the total solid angle? So at the center of the sphere. So total solid angle it will be equal to 4 pi r square divided by r square. Now how is this formula coming, 4 pi r square divided by r square? Because the total area will be the curved surface area of the sphere, that is 4 pi r square, and that divided by r square. So 4 pi r square divided by r square. So you will find that r square will get cancelled and it will become 4 pi. So the total solid angle at the center of this particular sphere will be 4 pi. So there is a rule that, I have taken a sphere, I could have taken some other three-dimensional object. The total solid angle at any internal point is always 4 pi. So the total solid angle at internal point of any closed object is always 4 pi. And so internal point of any closed object, the total solid angle will always be 4 pi. And the total solid angle at any external point of a closed object will be 0. So internal point of a closed object, solid angle will be 4 pi, and external point of a closed object, the solid angle will be 0. Suppose if you consider a sphere which encloses a charge of q, then if you take a small element of area dA on the surface of this sphere, then the flux, you know the formula, field into the area vector. So since it is a sphere, the field will be pointing this way, the area vector will also point this way. So the flux will be Q by 4 pi epsilon naught square into dA. Then you integrate it for the entire surface. So it will come Q by 4 pi epsilon naught into integral of dA by r square. Now you know that integration of dA will be 4 pi r square. So ultimately it will come Q by epsilon naught. So this is called Gauss's law, that if you have a closed surface and the enclosed charge inside the closed surface is Q, okay, any closed surface, if the enclosed charge is Q, then the flux of the electric field through this closed surface will be equal to Q by epsilon naught. This is called Gauss's law. So what is Gauss's law once again? If you have a closed surface, then the flux of the electric field through the closed surface is given by enclosed charge divided by epsilon naught. So this is called Gauss's law. Now in Gauss's law, you have to remember a couple of things. First of all, that in the Gauss's law, the Q which I have written, it is only the enclosed charge. Any charge which is outside the closed surface is not counted. So you have to keep that in mind. That is point number one. So Q has to be the enclosed charge, number one. Number two, remember you are calculating the flux due to the electric field in this entire region. So the electric field in this entire region could be due to any kind of charge. It could be due to the charge which is inside, it could be due to the charge which is outside. So remember that when you say this is the flux of the electric field, that is due to all kinds of charges. The electric field is due to all kinds of charges which are present anywhere, inside, outside, anywhere. But in the answer, that is the value of the flux, the Q which I have written is always the enclosed charge. So this has to be very clearly understood. So Q is always the enclosed charge, but when I say flux of the electric field, so electric field is due to every kind of charge present anywhere over here. So this is the topic for today, Gauss's law. So based on this, I am giving you the homework. Okay, so there is a cube whose each side is 55 centimeter. Enclosed charge is 1.8 microcoulomb. So the question is, due to this 1.8 microcoulomb, what is the net flux through the surface of this particular cube? That is question number 1. Okay, question number 2. There is a box. In the center of the box, there is a box, and through this box, the flux is 8 into 10 to the power 3 Newton meter square per coulomb. So there is a box through the box, the flux is 8 into 10 to the power 3 Newton meter square per coulomb. So the question is that what is the net charge? Okay, there is a box and the flux through the box is 8 into 10 to the power 3 Newton meter square per coulomb. The question is what is the net charge? This is question number 2. There is a sphere of 10 centimeter radius and the flux produced is 750 Newton meter square per coulomb. So there are two questions. One is that there is a point charge in the center of the sphere. So the question is that what will be this point charge, and if R becomes 20 instead of 10, then what will be the flux? So these are the two questions of question number 3. So once again, question number 3, there is a sphere of radius 10, enclosed charge at the center is Q, flux is 750 Newton meter square per coulomb. So if the radius became 20, then what would be the flux? And second question is, what will be the enclosed charge Q? And you have to submit the homework by 9 p.m. Wednesday. I'll end the session now. Bye all of you.